You trust your eyes. Every morning, you wake up and you see your bedroom ceiling, the familiar cracks in the paint, the way sunlight filters through curtains you have had for years. You walk outside and see your street, your neighborhood, the same trees and buildings you passed yesterday. Your brain tells you that you exist on solid ground beneath a protective blanket of blue. You believe it without question. But I want you to try something. Right now, wherever you are, look up. If you are inside, imagine the sky beyond your ceiling. If you are outside, find the brightest point of light you can see. That star, that planet, that distant sun burning across the void. Now imagine standing there. Imagine turning around and looking back toward where you came from. Where is home? Where is Earth? Would you even recognize it? Because here is the thing nobody tells you. The thing that should shake you to your core. The planet you are standing on right now. This world that feels so enormous, so permanent, so undeniably real. It looks completely different depending on where you are in the solar system. From some places, Earth is a brilliant blue jewel. From others, it is a pale speck, indistinguishable from the background stars. And from the farthest reaches of our cosmic neighborhood, it vanishes entirely. This is not a story about the planets. This is a story about what happens when you leave home and dare to look back. We need to start with something that seems obvious, but is actually quite profound. When you look at the night sky, you are not seeing the universe as it truly is. You are seeing a carefully curated illusion shaped by your position on a spinning rock orbiting a medium-sized star. From Earth, we see Venus as a brilliant evening star, Mars as a rust-colored wanderer, Jupiter as a steady beacon. We assume these perspectives are somehow correct, that this is what these worlds look like. But perspective is everything in astronomy. And the first perspective we need to understand is our own. Earth appears blue from space for two interconnected reasons. First, our oceans, which cover roughly 71% of the planet's surface, absorb red and yellow wavelengths of light while reflecting blue wavelengths back into space. Second, our atmosphere scatters shorter wavelengths of light more efficiently than longer ones, a phenomenon called Rayleigh scattering, named after the British physicist Lord Rayleigh, who first explained it mathematically in 1871. This is the same reason our sky appears blue during the day. The result is a world that shimmers, a planet wrapped in swirling white clouds against a backdrop of deep blue oceans and brown-green continents. When the Apollo 17 astronauts captured the famous blue marble photograph on December 7, 1972, they gave humanity something we had never truly had before, a portrait of home. But that portrait changes depending on where the artist stands. From the International Space Station, orbiting at approximately 400 kilometers above Earth's surface, astronauts see our planet in breathtaking detail. They can make out individual cities at night, trace the meandering paths of rivers, watch hurricanes spiral across ocean basins. At this distance, Earth fills most of their field of view. It is impossible to ignore. Space philosopher Frank White coined the term overview effect in 1987 to describe what happens to astronauts who see Earth from this perspective. In interviews with dozens of space travelers, White discovered something remarkable. Viewing Earth from orbit triggers a profound cognitive shift. Astronauts report feeling an overwhelming sense of the planet's fragility, its beauty, and the interconnectedness of all life upon it. You develop an instant global consciousness, Apollo 14 astronaut Edgar Mitchell told White. A people orientation, an intense dissatisfaction with the state of the world, and a compulsion to do something about it. This is what Earth does to you when you are close enough to see it clearly. The thin blue line of atmosphere, the lack of visible borders, the realization that everything you have ever known, every war, every love, every triumph and failure, all of it happened on that fragile sphere. But what happens when you start moving away? Let us begin our journey at the closest planet to the Sun, Mercury. Mercury orbits at an average distance of 58 million kilometers from the Sun, about 0.39 astronomical units, where 1 AU is the distance from Earth to the Sun. From Mercury, Earth is not close by any stretch of imagination. At their nearest approach, the two planets are separated by approximately 77 million kilometers. At their farthest, that gap stretches to nearly 222 million kilometers. On July 19, 2013, NASA's Messenger spacecraft, which orbited Mercury from 2011 until its planned crash landing in 2015, turned its cameras toward the inner solar system. The same day that Cassini photographed Earth from Saturn, Messenger captured our planet from the opposite direction, looking outward from a vantage point just 50 million kilometers from the Sun. In that image, Earth appears as a small but distinct point of light, bright, unmistakably there. You can even make out the Moon, a fainter speck just below and to the left of Earth. From Mercury's surface, a world of temperature extremes ranging from 430 degrees Celsius on the sunlit side to negative 180 degrees on the dark side, an observer would see Earth as a morning or evening star, much as we see Venus from here. It would appear as a brilliant blue-white point, brighter than any star in the Mercurian sky, trailing the Sun as it rises or sets over the cratered, airless landscape. But here is where it gets interesting. Unlike our view of Mercury, which shows a tiny dot that never strays far from solar glare, an observer on Mercury would see Earth go through phases. Just as Galileo observed Venus waxing and waning through his telescope in 1610, observations that helped prove the heliocentric model of the solar system. Someone watching Earth from Mercury would see it transform from a thin crescent to a nearly full disk and back again. When Earth is full at what astronomers call superior conjunction, when the Sun lies between Mercury and Earth, our planet would appear at its brightest. But you would never see it then, because it would be lost in the Sun's overwhelming glare. The best views would come when Earth is at its greatest elongation from the Sun as seen from Mercury. In those moments, our planet would blaze against the black sky, a brilliant beacon of blue and white, clearly showing its disk-like nature even to the naked eye. Think about that. From Mercury, you could see Earth well enough to know it was a world, not just a point of light, but an actual place. You might even glimpse the Moon beside it, the pair dancing together like a binary system. This is closer than most people imagine. Mercury, the closest planet to the Sun, still offers a recognizable view of home. Moving outward, we come to Venus, Earth's closest planetary neighbor in terms of physical proximity, though it is not the planet that spends the most time nearest to us. That honor, surprisingly, goes to Mercury due to the peculiarities of orbital mechanics. Venus approaches Earth more closely than any other planet. At inferior conjunction, when Venus passes between Earth and the Sun, the two worlds can be separated by as little as 38 million kilometers. This happened most recently on January 9, 2022. when Venus drew within 39.5 million kilometers of Earth. But Venus is a challenging place to imagine observing Earth from. Its atmosphere is catastrophically thick, 90 times the surface pressure of Earth's atmosphere, composed primarily of carbon dioxide with clouds of sulfuric acid. The surface temperature averages 464 degrees Celsius, hot enough to melt lead. No spacecraft has survived on Venus's surface for more than 127 minutes, a record set by the Soviet Venera 13 lander in 1982. Even if you could somehow stand on that hellscape, you would see nothing of the sky. The dense cloud cover permanently obscures the view. Venus is a world of eternal swirling twilight, with no direct sunlight ever reaching the surface. But let us imagine you are above those clouds, perhaps orbiting Venus, or standing on the deck of some impossibly advanced vessel, hovering in the upper atmosphere, where temperatures and pressures are more Earth-like. From this vantage point, Earth would be stunning. At inferior conjunction, when Venus is closest, Earth would appear large and bright, though ironically, you could not see it well then, because it would be fully illuminated from behind, lost in solar glare. The best viewing would come at Venus's greatest elongation from the Sun, when Earth appears to the side of our star. From Venus's perspective, Earth would display phases, just as Venus does from Earth. When Venus is at greatest elongation, Earth would appear as a brilliant half disk, its blue oceans and white cloud patterns potentially visible through a good telescope. The Moon would be clearly visible as a companion, dancing around Earth like a tiny satellite, which, of course, it is. No spacecraft has ever photographed Earth from Venus's vicinity with the kind of detail we might wish for. The various Venus missions have been focused on the planet itself, not on looking back toward home. But calculations and simulations give us a clear picture of what we would see. Earth, from Venus, would be the third brightest object in the sky after the Sun, and, occasionally, the Moon. It would be a familiar sight, close enough to appear as more than a mere point, bright enough to cast shadows on a dark enough night, close enough to remind you that home is just next door, cosmically speaking. And then there is the Moon. The Moon is not a planet, but it deserves a place in this story because it is the only other world where humans have actually stood and looked back at Earth. Everything else we know comes from robotic spacecraft, mathematical calculations, and careful extrapolation. But the Moon gave us direct experience. On December 24th, 1968, Apollo 8 astronauts Frank Borman, Jim Lovell, and Bill Anders became the first humans to orbit another celestial body. They had traveled approximately 384,000 kilometers from Earth, a journey of about 3 days, and were circling the Moon at an altitude of around 111 kilometers. As their spacecraft came around from the far side of the Moon on its fourth orbit, something unexpected happened. Bill Anders looked out his window and saw Earth rising above the lunar horizon. "Oh my God, look at that picture over there," he exclaimed, his voice captured on the onboard recorder. "Here's the Earth coming up. Wow, is that pretty?" What followed was a scramble for color film and a few hurried photographs that would change human history. The image Anders captured, now known as Earthrise, has been called the most influential environmental photograph ever taken by nature photographer Galen Rowell. In the photograph, Earth appears as a small blue and white marble rising above the stark grey lunar surface. It fills only a tiny portion of the frame, yet it commands all attention. The contrast is devastating. The dead, cratered moon in the foreground, the living, breathing Earth suspended in blackness. From the moon, Earth's apparent size is about 4 times larger than the moon appears from Earth. It spans roughly 2 degrees of arc, about 4 times the width of your thumb held at arm's length. You can see continents, you can see oceans, you can watch weather systems move across its face. But here is the strange part. If you were standing on the moon's near side, the side that always faces Earth, our planet would never rise or set. It would hang in the sky, perpetually visible, slowly turning as it rotates on its axis. You could watch days and nights pass on Earth, see the Terminator lines sweep across continents, observe the progression of seasons as cloud patterns shifted. Earth would be your clock, your calendar, your constant companion in an otherwise dead sky. The astronauts who walked on the moon all spoke of this view with something approaching reverence. Jim Lovell, speaking during the Christmas Eve broadcast from lunar orbit, said, "The vast loneliness is awe-inspiring, and it makes you realize just what you have back there on Earth. What you have back there. Such a simple phrase, such a profound sentiment." From the moon, Earth is still close enough to look like home. You can see it. You can almost reach it. The knowledge that everything you love is right there, visible, separated from you by only 3 days of travel, provides a strange comfort. But we are about to leave that comfort behind. Mars changes everything. When NASA's Spirit rover landed in Mars's Gusev crater on January 4, 2004, it carried a suite of scientific instruments designed to study Martian geology. But about 2 months after landing, on March 8, 2004, Spirit's camera turned skyward, just before sunrise, and captured something unprecedented. The first photograph of Earth taken from the surface of another planet. In that image, Earth appears as a tiny point of light in the Martian dawn sky. It looks like a star, albeit a particularly bright one. But there is nothing to immediately distinguish it from the thousands of other stellar pinpricks visible from Mars. Nearly a decade later, on January 31, 2014, the Curiosity rover, which had landed in Gale crater in August 2012, took an even more striking image. About 80 minutes after sunset on the rover's 529th Martian day, Curiosity's Mastcam captured Earth and the Moon together in the Martian twilight. At that moment, Earth was approximately 160 million kilometers from Mars. In the photograph, our planet appears as the brightest point of light slightly left of center, with the Moon visible as a smaller speck just below it. NASA's official description notes that a human observer with normal vision, if standing on Mars, could easily see Earth and the Moon as 2 distinct bright evening stars. Think about what that means. From Mars, you can still see the Moon as separate from Earth with the naked eye. The system that has governed our tides, shaped our mythologies, and inspired countless generations is still visible as a binary pair, but barely. On September 5th, 2024, Curiosity captured something even more remarkable. The first ever image of Earth and Phobos, one of Mars's 2 small moons, together in the same frame. In that photograph, Earth appears as a tiny dot beside the larger but still small disk of Phobos, rising in the Martian night sky. From Mars, Earth has become a point of light. You know it is there. You know it is your home. But it has lost its disk-like appearance to the naked eye. You cannot see the blue of the oceans or the white of the clouds. You cannot watch weather systems move or seasons change. Earth, from Mars is a memory rendered in light. And here is something that keeps planetary scientists up at night: the psychological weight of this transformation. When astronauts orbit Earth in the International Space Station, they can see their home countries. They can watch the sun set over familiar coastlines. Japanese astronaut Soichi Noguchi once spent hours photographing cities he had visited, pointing his camera at places that held personal meaning. European astronauts have captured their hometowns. American astronauts have traced the outline of the Great Lakes, remembering summers spent on those shores. That connection, that ability to see home, provides psychological grounding. It reminds space travelers that they are still connected to the world they left behind. The Earth fills their windows. It dominates every view. It is impossible to forget. But Mars, on Mars, you cannot see your hometown. You cannot see your country. You cannot see your continent or your hemisphere, or even the disk of the planet itself. All you can see is a point of light, brighter than most stars, but indistinguishable from them without careful study. NASA's behavioral health experts have studied this problem extensively. They call it Earth out-of-view psychology, and they consider it one of the most significant challenges facing future Mars missions. Not the radiation exposure, not the bone loss from microgravity, not the technological challenges of keeping humans alive for years in deep space. The hardest part might be the loneliness of looking up and not being able to see home. Dr. Nick Canaz, a psychiatrist who has spent decades studying the psychology of spaceflight, has warned that the transition from low Earth orbit to deep space will fundamentally change the astronaut experience. In interviews, he has described the phenomenon as the Earth viewpoint problem, the challenge of maintaining psychological health when the visual connection to home is severed. Consider what Mars colonists might experience. They wake up each Martian morning, a sol lasting 24 hours and 37 minutes, and they step outside into a landscape of rust-red dunes and ancient dried riverbeds. The sky is butterscotch-colored, tinted by suspended dust particles. Phobos, the larger of Mars's two moons, races across that sky, rising in the west and setting in the east just 4 hours later. And somewhere, if the geometry is right, there is a bright point of light that they were taught to recognize. That is Earth. That is where humanity began. That is where their grandparents still live, or lived, or where their great-grandchildren will never visit. How do you maintain sanity when home is a star? Mars's distance from Earth varies dramatically depending on where both planets are in their orbits. At the closest approach, called opposition, the two worlds can be as near as 54.6 million kilometers, though the actual closest approach varies from opposition to opposition. At their farthest, when the sun lies between them, Mars and Earth can be separated by as much as 401 million kilometers. This variability has profound implications for communication. Radio signals travel at the speed of light, which means a message from Mars takes between 3 and 22 minutes to reach Earth, depending on the planetary positions. A question asked from Mars would not receive an answer for at least 6 to 44 minutes. Imagine calling home and waiting half an hour for your mother's voice to reach you. Imagine watching the evening news from Earth, knowing that whatever you are seeing happened 20 minutes ago. Imagine trying to maintain relationships across a time delay that makes conversation impossible. This is not science fiction. This is the reality that future Mars explorers will face. And while engineers can build spacecraft and architects can design habitats, no one has yet figured out how to solve the problem of distance. Earth's brightness in the Martian sky changes significantly over time. At opposition, when Earth is at its closest and fully illuminated from Mars's perspective, it would blaze brilliantly in the pre-dawn or post-dusk sky. At conjunction, when Earth is on the far side of the Sun, it would be invisible entirely, lost in solar glare. What does this mean for future Mars colonists? It means that Earth will be a familiar point of light, one they can find easily on any clear Martian night when the geometry is right. It means they will be able to point up and say, "There, that is where I came from." But it also means that home will feel very, very far away. Frank White, the space philosopher who coined the term overview effect, has speculated about what he calls the Copernican perspective, the awareness of being part of the solar system that would come from seeing Earth from Mars. Unlike the overview effect experienced in low Earth orbit, where Earth dominates the view, the Copernican perspective would involve seeing Earth as a point of light, as just another celestial body among many. Seeing the Earth from Mars, I call this the Copernican perspective, White told Space.com in 2022. The awareness of being part of the solar system when one is on another planet. The Earth is going to be a point of light. You will not see continents and oceans on Earth. There is a psychological dimension to this that scientists are only beginning to explore. Right now, astronauts on the International Space Station can look down at Earth anytime they want. They can see their home countries, watch cities light up at night, feel connected to the world they left behind. But on Mars, you might see a bright dot when the viewing geometry is favorable, and you might see nothing at all when it is not. How does that change a person? How does it change a civilization? Beyond Mars lies the asteroid belt, and beyond that, the realm of the giants. Jupiter, Saturn, Uranus, Neptune. These are worlds so distant that Earth shrinks to insignificance. But before we reach Jupiter, consider for a moment what we are leaving behind. The asteroid belt spans roughly 179 million to 329 million kilometers from the Sun. It is not, as science fiction often depicts, a dense field of tumbling rocks that spacecraft must navigate carefully. In reality, the belt is mostly empty space, with millions of kilometers between significant objects. The total mass of all asteroids combined is less than 4% of the Moon's mass. Still, within this belt lies Ceres, the largest asteroid now classified as a dwarf planet, with a diameter of about 940 kilometers. NASA's Dawn spacecraft orbited Ceres from 2015 to 2018, returning images of a strange world marked by bright spots of carbonate minerals and a lonely mountain called Ahuna Mons. If you stood on Ceres and looked back toward Earth, you would see our planet as a moderately bright star, brighter than most background stars certainly, but already losing the distinctive appearance it had from Mars. From Ceres, Earth's apparent magnitude would be around 0.15 to Hlaum-1, comparable to the brighter stars in our sky like Arcturus or Vega. The Moon would be visible only as a very faint companion, if at all. The separation between Earth and Moon, so obvious from Mars, begins to blur into a single point of light as distance increases. And then we reach Jupiter. Jupiter orbits the Sun at an average distance of 778 million kilometers, more than 5 times the Earth-Sun distance. At its closest approach to Earth, Jupiter is still about 588 million kilometers away. at its farthest, nearly 969 million kilometers. To grasp what this means, consider light itself. A photon leaving Earth's surface will take roughly 33 minutes to reach Jupiter at closest approach, and about 54 minutes when Jupiter is at its farthest. Any future spacecraft traveling between these worlds would require years of travel time with current technology. No spacecraft has ever photographed Earth from Jupiter's vicinity in a way that captured public imagination. The Juno spacecraft, which has been orbiting Jupiter since 2016, took images of Earth and the Moon during its October 2013 flyby, a gravity assist maneuver designed to boost its speed toward the outer solar system. In those images, Earth and the Moon appear as small but distinct disks, clearly showing that both are worlds rather than mere points of light. But that was taken from a relatively close distance as Juno passed by. From Jupiter itself, the picture is very different. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, occasionally turned its cameras toward the inner solar system. But the spacecraft's primary mission was to study Jupiter and its moons, not to photograph distant Earth. The images that do exist show Earth as a faint point, almost lost against the cosmic background. From within Jupiter's system, from the volcanic hellscape of Io, or the frozen ocean world of Europa, Earth would be a dim, distant memory. You might be able to find it with careful navigation, knowing exactly where to look based on calculations of orbital mechanics, but you would not be able to simply glance up and see home. At Jupiter's distance, Earth would appear as a faint point of light, much fainter than it appears from Mars, and far harder to pick out from the background stars. Its angular size would be roughly 0.3 arcseconds, meaning you would need a powerful telescope to see it as anything other than a pinprick. To put that in perspective, from Earth, we can see Jupiter as a disk with the naked eye under ideal conditions and easily with binoculars. But from Jupiter, Earth would be a dim star-like object, visible to the naked eye, but showing no discernible disk. Here is something striking to consider. From Jupiter, you could still see Earth. It would be faint, perhaps magnitude +1 or +2, roughly as bright as the stars in the Big Dipper. But it would be there. The Sun would still dominate Jupiter's sky, appearing about 3.7 times smaller than it does from Earth, but still obviously different from any star. But Earth would be just another point of light, distinguishable mainly by its bluish color and its position in the sky relative to the Sun. Imagine standing somehow on one of Jupiter's moons, Io perhaps, with its volcanic sulfur plains and constant eruptions, or Europa with its ice-covered ocean and the promise of possible life below. You look up and you see Jupiter dominating the sky, its storms and bands clearly visible, the great red spot a persistent eye staring back at you. And somewhere, low in the sky, there is a faint blue dot. That is Earth. That is where you came from. That is where everyone you ever knew once lived, or lives still, or will live. Can you find it? Can you point to it confidently? Or has home become just another star among billions? Saturn presents an even more extreme case. The ringed planet has captivated human imagination since Galileo first turned his telescope toward it in 1610. He could not understand what he was seeing. His primitive optics showed what looked like handles or ears attached to the planet. It was not until Christian Huygens observed Saturn in 1655 that astronomers understood they were looking at a ring system. Saturn orbits at an average distance of 1.4 billion kilometers from the Sun, making it nearly 10 times as far from our star as Earth is. Light takes about 80 minutes to travel from the Sun to Saturn. The planet's year, one complete orbit around the Sun, lasts more than 29 Earth years. The Cassini mission, launched in 1997 and arriving at Saturn in 2004, spent 13 years exploring this incredible system. During that time, Cassini revolutionized our understanding of Saturn, its rings, and its 146 known moons. It discovered water geysers erupting from Enceladus, mapped the methane lakes of Titan, and revealed the intricate structure of the rings in stunning detail. But Cassini also did something else, something that may prove to be one of the most culturally significant achievements in the history of space exploration. On July 19, 2013, a date that should be remembered more than it is, NASA's Cassini spacecraft did something extraordinary. Orbiting Saturn at a distance of about 1.44 billion kilometers from Earth, Cassini slipped into Saturn's shadow and turned to photograph the planet, its rings, and, in the background, the inner solar system. The event was conceived and promoted by imaging team leader Caroline Porco, who had been part of the Voyager imaging team and understood the power of such images. She nicknamed it the day the Earth smiled, and NASA invited people around the world to look up at Saturn and wave at the precise moment Cassini was imaging Earth. People in 40 countries participated, creating a global moment of cosmic awareness. The event became something unprecedented, a coordinated act of cosmic self-reflection. Millions of people scattered across continents looked up at the sky at the same time and waved at a spacecraft orbiting a planet nearly 1 billion miles away. They knew they could not be seen. They knew the gesture was purely symbolic. But they did it anyway. Why? Because it mattered. Because the act of looking up and acknowledging our place in the cosmos, of recognizing that a machine built by human hands was photographing Earth from the rings of Saturn, felt important, felt necessary. The resulting photograph is haunting. Saturn dominates the frame, its rings glowing golden as they are backlit by the sun. 7 of Saturn's moons are visible, and there, below and to the right of Saturn, beyond the outer edge of the rings, is a tiny pale blue dot. That is Earth. It spans less than a pixel. It is barely distinguishable from the background noise. If you did not know exactly where to look, you might miss it entirely. Porco described the image in terms that echoed Carl Sagan's famous passage about the original pale blue dot. It is a great gift and special honor, this opportunity to be part of such a meaningful, historic event, to turn our camera away from the rings and moons of Saturn and capture the blue, life-sustaining orb that is our world in the same frame with the most beautiful planet in our solar system, Saturn and its rings. This was not the first time Cassini had photographed Earth from Saturn. In September 2006, during a similar eclipse observation, the spacecraft captured another image of Earth through Saturn's rings. That image, too, shows our planet as a minuscule point of light, beautiful but almost unbearably small. But the 2013 image was different because it was participatory. People knew it was happening. They looked up, they smiled, they waved, and somewhere, 1 billion miles away, a machine captured their existence as a single pixel of pale blue light. At Saturn's distance, an average of 1.4 billion kilometers from the Sun, nearly 10 times the Earth-Sun distance, our planet's apparent brightness has faded to roughly magnitude plus 0.8. that is still visible to the naked eye, comparable to some of the brighter stars in our sky. But it is no longer impressive. It is no longer a beacon. From Saturn, Earth is a faint blue speck that you might see if you knew exactly where to look and conditions were perfect. It would be lost among the countless other stars visible in Saturn's sky. Stars that, from Saturn's vantage point, would appear essentially identical to how they appear from Earth, since the distances to other stars are so vast that our solar system's dimensions are negligible. The Canadian Space Agency has noted the psychological implications of this distance for future deep space travelers. From Saturn, Earth is not just far away. It is small enough to question whether it really matters at all. The overview effect that transforms astronauts in low Earth orbit depends on seeing Earth as a dominant, beautiful presence. From Saturn, that presence has shrunk to a pixel. What happens to the human psyche when home becomes almost invisible? We are not done yet. Beyond Saturn lie Uranus and Neptune, the ice giants, worlds so remote that they were unknown to ancient astronomers and remained undiscovered until 1781, Uranus, and 1846, Neptune. Uranus was discovered by William Herschel, a German-born British astronomer who initially thought he had found a comet. Neptune was discovered through mathematical prediction. Astronomers noticed irregularities in Uranus's orbit that suggested another massive planet was gravitationally tugging on it. Johann Galle, using calculations provided by Urbain Le Verrier, spotted Neptune within 1 degree of its predicted position on September 23, 1846. These worlds exist in a realm of perpetual twilight. The Sun from Uranus's distance would appear as a bright point, still clearly distinguishable from stars, still recognizably the center of our solar system, but providing only 1/400th the light it provides on Earth. From Neptune, the Sun would be even dimmer, roughly 1/900th of its brightness from Earth's vantage point. Uranus orbits at an average distance of 2.87 billion kilometers from the Sun, about 19 times the Earth-Sun distance. Neptune is even farther, averaging 4.5 billion kilometers out, 30 times the Earth-Sun distance. At these distances, the Sun still dominates the sky. But Earth has become something you have to search for. No spacecraft has orbited either of these worlds. Voyager 2 flew past Uranus in January 1986 and Neptune in August 1989. But those were brief encounters lasting mere hours, not extended missions spanning years. The spacecraft's cameras were focused on the planets themselves, their moons, their rings, their atmospheric dynamics. But from within those systems, Earth would appear as an exceedingly faint point of light, perhaps magnitude +3 or +4, still technically visible to the naked eye, but only under perfect conditions and with young, sharp eyes. Let that sink in for a moment. From Neptune, a planet within our own solar system, a world that shares our Sun, Earth has become difficult to see with the naked eye. At Uranus's distance, the Sun would appear roughly 400 times fainter than it does from Earth. You could still see it as a brilliant point, brighter than any star, but it would no longer warm you. The average temperature on Uranus is about -224 degrees Celsius. The planet's atmosphere is composed primarily of hydrogen and helium, with small amounts of methane that give it its distinctive blue-green color. At Neptune's distance, the Sun would appear 900 times fainter, a bright star, certainly the brightest in the sky by far, but no longer recognizably a sun as we understand the term. Neptune's average temperature is -214 degrees Celsius, despite being farther from the Sun than Uranus. This is because Uranus, for reasons not fully understood, radiates almost no internal heat, while Neptune radiates more than twice as much energy as it receives from the Sun. And Earth would be invisible without optical aid at Neptune's distance. It would be a faint speck that only the most powerful telescopes could resolve, and even then, it would show nothing but a point of light with perhaps a faint bluish tinge. From Neptune, you would need a map to find your home. You would need to know the constellations, understand the geometry, calculate the position, and even then, you might not be certain. Is that faint glimmer Earth, or is it some other star in that direction? Without instruments, without mathematical certainty, home becomes indistinguishable from the cosmic background. The psychological isolation of such a distance is difficult to comprehend. We evolved on savannas and in forests. Our eyes adapted to seeing perhaps a few kilometers in any direction. Our brains developed to understand distances measured in days of walking, not billions of kilometers measured in light hours. Even with modern travel, most humans never venture more than a few thousand kilometers from their birthplace. The average person lives, works, loves, and dies within a region they could cross in a day's driving. From Neptune, Earth is 4.5 billion kilometers away. Light from Earth takes more than 4 hours to reach Neptune. Any message sent home would not receive a reply for at least 8 hours, and realistically, much longer. The delay would make conversation impossible. The distance would make return almost unthinkable. And yet, even from Neptune, Earth would technically still be visible to sensitive instruments. Faint, uncertain, but detectable. That changes at our next destination. On July 14, 2015, NASA's New Horizons spacecraft made history by flying past Pluto, the first spacecraft ever to explore the distant dwarf planet. At that moment, New Horizons was approximately 4.67 billion miles, about 7.5 billion kilometers from Earth. That is about 50 astronomical units, 50 times the distance from Earth to the Sun. From Pluto's distance, Earth would be extraordinarily faint. Calculations suggest it would appear at roughly magnitude plus 6.7, at or beyond the limit of human naked eye visibility, even under perfect conditions. You might see it if you had exceptional eyes and knew exactly where to look. Or you might not see it at all. The Sun from Pluto appears as a brilliant point, still clearly the brightest object in the sky, but small. If you held up a pin at arm's length, the Sun would appear smaller than the head of that pin. It provides light, but not warmth. It is recognizably a sun, but only just, and Earth is lost entirely. This is the boundary. Somewhere between Neptune's orbit and Pluto's distant wanderings, Earth transitions from a barely visible speck to an essentially invisible nothing. Home disappears. New Horizons did not photograph Earth from Pluto. The geometry was not favorable, and the spacecraft's instruments were focused on other priorities. But it did something arguably more profound. In 2020, on the 30th anniversary of the original pale blue dot image, New Horizons demonstrated just how far it had traveled by imaging the nearby stars Proxima Centauri and Wolf 359. Due to the spacecraft's immense distance from Earth, by then over 7 billion kilometers, the stars appeared in slightly different positions than they would from Earth. This parallax effect proved visually that New Horizons had traveled far enough to see the universe from a genuinely different perspective. If New Horizons could turn its cameras toward Earth, it would see a point of light even fainter than the pale blue dot captured by Voyager 1. At some point in its journey into the Kuiper Belt and beyond, new horizons will cross an invisible threshold, the distance at which no instrument on board could detect Earth at all. When that happens, and it will happen, there will be a human-made object for which Earth is no longer visible by any means. That thought should keep you up at night. Speaking of Voyager 1, this is where the story reaches its emotional climax. This is where we confront what it truly means to disappear into the cosmic vastness. Voyager 1 was launched on September 5th, 1977, 16 days after its twin, Voyager 2. The probes were designed to take advantage of a rare planetary alignment that occurs only once every 176 years, a configuration that would allow a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune using gravity assists to slingshot from one world to the next. Voyager 2 took the grand tour, visiting all 4 giant planets. Voyager 1 was sent on a faster trajectory that allowed closer flybys of Jupiter and Saturn, but ruled out visits to the ice giants. In exchange for sacrificing Uranus and Neptune, Voyager 1 gained speed, becoming the fastest object ever launched by humanity and ensuring it would reach interstellar space first. By February 1990, Voyager 1 had completed its planetary encounters and was coasting outward, its primary mission long accomplished. It had photographed the Great Red Spot in unprecedented detail, discovered active volcanoes on Jupiter's moon Io, revealed the complexity of Saturn's rings, and provided close-up views of Titan's smog-shrouded atmosphere. The spacecraft was heading for interstellar space, its trajectory carrying it ever farther from the Sun. Most of its cameras had been shut down to conserve power. There was no scientific reason to photograph anything else. At those distances, there were no planetary targets to image. But Carl Sagan had an idea. Sagan, who had been a member of the Voyager imaging team and one of the mission's most eloquent advocates, proposed that before the cameras were permanently switched off, Voyager 1 should turn around and photograph the planets of the solar system one last time. It would be a family portrait, a series of images showing Mercury, Venus, Earth, Mars, Jupiter, and Saturn as seen from the outer solar system. The idea faced resistance. Some argued that such photographs had no scientific value. The planets would appear as mere points of light, tiny, featureless specks showing nothing that ground-based telescopes could not already see better. Others worried that pointing the cameras toward the Sun, even from such a distance, might damage the sensors. But Sagan persisted, and eventually, NASA agreed. On February 14th, 1990, Valentine's Day, Voyager 1 was commanded to turn its camera around and take one last look at the solar system. The spacecraft was approximately 6 billion kilometers from Earth, about 40.5 astronomical units, when it snapped a series of 60 images that would become known as the family portrait. The images were designed by Candy Hansen of the Jet Propulsion Laboratory and compiled with help from space scientist William Cosman. The sequence started with Neptune and worked inward, taking photographs of each visible planet plus wide-angle shots of the sky between them. One of those images showed Earth. The photograph was taken at 04:48 GMT on February 14th, 1990, just 34 minutes before Voyager 1's cameras were powered off forever. The data took months to transmit back to Earth. Voyager's radio signal, traveling at the speed of light, required nearly 5.5 hours to cover the distance, and the Deep Space Network was busy with other missions. The final download occurred on May 1st, 1990. And when scientists processed the images, they found something extraordinary. Earth appeared as a tiny blue dot, suspended in a beam of scattered sunlight. The sunbeam was an artifact of the camera optics, light scattered by the camera's elements as it pointed toward the sun. But the effect was profound. Our planet, caught in a shaft of light like a mote of dust illuminated by a beam from a window. That dot was less than a single pixel in size. It was barely distinguishable from camera noise. If you did not know exactly where to look, you might never find it. Carl Sagan wrote about this image in his 1994 book, also titled Pale Blue Dot. His words have become perhaps the most famous passage in modern astronomy, a meditation on human significance in the face of cosmic vastness. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. He continued, the aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The passage builds to its devastating conclusion. The Earth is a very small stage in a vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors, so that, in glory and triumph, they could become the momentary masters of a fraction of a dot. And then, perhaps, the most important sentence Sagan ever wrote: there is no hint that help will come from elsewhere to save us from ourselves. In 2020, for the 30th anniversary of the image, NASA released an updated version processed by JPL engineer Kevin M. Gill, using modern techniques to enhance the original data while respecting its intent. The new processing revealed more detail in the sunbeam, made the pale blue dot slightly clearer, but fundamentally preserved the original's haunting quality. But here is the thing about the pale blue dot that many people miss. It was taken from inside the solar system. Voyager 1 has since crossed the heliopause, the boundary where the solar wind gives way to interstellar space, becoming the first human-made object to enter the interstellar medium. As of late 2025, Voyager 1 is over 24 billion kilometers from Earth, more than 160 astronomical units away. At that distance, Earth is utterly, completely invisible. No camera on Voyager 1. Even if the spacecraft's cameras still functioned, which they have not since 1990, could possibly detect Earth. The light from our planet is simply too faint, overwhelmed by the background glow of distant stars and the darkness of interstellar space. From Voyager 1's current position, Earth does not exist visually. There is no point of light you could point to and say, there is home. There is only a direction, a memory of where home used to be visible before the distances became too great. Voyager 1 is still communicating with Earth via radio signals, which travel at the speed of light. As of now, those signals take over 22 hours to reach Earth. A command sent to the spacecraft will not receive a response for nearly 2 days. Someday, perhaps in a few decades, perhaps sooner, Voyager 1's power supply will fail. The radioisotope thermoelectric generators that have kept it alive since 1977 are slowly decaying. When they can no longer produce enough power to operate even the most basic systems, Voyager 1 will fall silent, and it will continue drifting through interstellar space, carrying the golden record, a phonograph record containing sounds and images from Earth, towards stars it will not reach for tens of thousands of years. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star Gliese 445 in the constellation Camelopardalis. It will not stop there. It will simply drift past, silent and dark, a ghost ship from a civilization that once existed on a pale blue dot in the Milky Way galaxy. So what does all of this mean? We have traveled, in our imagination, from the International Space Station at 400 kilometers altitude to the interstellar void beyond the heliopause. We have watched Earth transform from a dominating presence that fills the window to a faint blue speck to nothing at all. This progression tells us something profound about our place in the cosmos. It is not just that we are small, though we are unimaginably so. It is that our visibility is finite. There is a distance beyond which Earth cannot be seen, no matter how good your eyes or how powerful your telescope. Consider the implications of this. When we send spacecraft to other worlds, we are not just exploring the universe. We are pushing back against our own invisibility. We are saying, we exist and we want to be known. The universe does not care about us. It does not know we exist. The light from our planet, spreading outward at 299,792 kilometers per second, will eventually become too diffuse to detect against the cosmic background. Our radio signals, already too faint to be noticed by any civilization more than a few light years away, will fade into cosmic noise. In about 4 billion years, the Andromeda galaxy will collide with the Milky Way. The Sun, by then a red giant, will have already consumed the inner solar system. Earth will have long since ceased to exist as we know it. These are not comfortable thoughts, but they are necessary ones, because here is what the pale blue dot and all the images of Earth from space ultimately teach us. We have each other. We have this moment. We have this world right now, with its oceans and forests and cities and billions of human beings struggling and dreaming and loving and dying. There is no backup Earth. There is no planet B. There is no cavalry coming from the stars to save us from our own stupidity or cruelty or short-sightedness. And yet there is something magnificent about this, something that should make you feel not smaller, but larger, not insignificant, but impossibly, improbably lucky. You exist on the one world in our solar system where conditions align to create life. You exist at the one moment in cosmic history when a species has developed the technology to see itself from space, to send probes to other planets, to look back at home and understand what we are seeing. The dinosaurs ruled Earth for 165 million years and never knew what their planet looked like from space. The trilobites thrived in ancient oceans for 270 million years without ever dreaming that their world was a sphere orbiting a star. For most of Earth's 4.5 billion year history, life existed without any awareness of its cosmic context. But we know, we have seen, we have photographed Earth from Mercury and Mars and Saturn and beyond. We have sent our robotic emissaries to the edge of interstellar space with messages for whoever might find them. Every photograph of Earth from space, from the blue marble to Earthrise to the pale blue dot, is an act of cosmic self-awareness. We are the universe looking at itself, trying to understand what it sees. When Bill Anders photographed Earthrise in 1968, He said something that crystallizes this perfectly. We came all this way to explore the moon, and the most important thing is that we discovered the Earth. That is what happens when you leave home and look back. You discover home for the first time. The next time you look up at the night sky, I want you to try something different. Do not look at the stars as distant, unreachable points. Do not think of the planets as abstract destinations on a map you will never travel. Instead, imagine yourself there. Imagine standing on the rust-colored sands of Mars, or floating above the acid clouds of Venus, or orbiting Saturn's ice and rock rings. Now turn around. Look back toward the sun. Where is Earth? Can you find it? Is it bright enough to see? Does it look like a world? Or does it look like just another star? This exercise will not give you the overview effect. Only space travel can do that. But it will give you something almost as valuable, a sense of perspective. A reminder that your problems, your triumphs, your entire life, all of it happens on a small, rocky world that can barely be seen from the next planet over. Consider the scale of what we have discussed today. From Mercury, Earth appears as a bright evening star, notable, visible, clearly important. From Mars, it becomes a point of light with its moon visible beside it. From Jupiter, it fades to a dim speck among millions of other specks. From Saturn, it shrinks to less than a pixel. From Neptune, it requires instruments to detect. From Pluto and beyond, it disappears entirely. Each step outward is a step away from certainty, from visibility, from significance, and yet each step also represents an expansion of human achievement, human curiosity, human courage. We are a species that refuses to stay home. We built ships and crossed oceans, not knowing what lay beyond the horizon. We built aircraft and flew despite thousands of years of failure. We built rockets and escaped our planet's gravity, establishing a foothold in space that we have maintained continuously since November 2000, when the first crew arrived at the International Space Station. That foothold will grow. Artemis will return humans to the moon. SpaceX and other companies are developing vehicles capable of reaching Mars. Plans are being drawn for space stations in lunar orbit, for permanent bases on the moon's surface, for eventual crewed missions to the outer solar system. Each of these missions will carry with them new opportunities to photograph Earth from new vantage points. Each will add to our collection of images showing home from afar, and each will deepen our understanding of what we are and where we fit in the cosmic order. That is not a reason for despair. That is a reason for wonder. We are the species that learned to leave our planet, look back, and understand what we saw. We are the species that sent Voyager to the edge of interstellar space with a message for anyone who might find it. A golden record containing music and greetings and the sounds of Earth, our calling card to the cosmos. We are the species that named a photograph the day the Earth smiled and invited the whole world to participate, turning a robotic observation into a moment of collective human consciousness. And we are just getting started. Within your lifetime, humans will likely set foot on Mars. They will look up into the butterscotch sky, find that faint blue point of light, and feel what no human has ever felt before, the weight of 55 million kilometers between themselves and everyone they have ever known. Some of them will struggle with it. Some will be overwhelmed by the distance, the isolation, the impossibility of casual return. but others will find something profound in that separation, a clarity that can only come from true distance, a perspective that can only be gained by genuinely leaving home behind. Carl Sagan, in his meditation on the pale blue dot, wrote, "There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we have ever known." He was right, but I think there is something else the pale blue dot shows us. It shows us that we are capable of transcendence, that we can build machines to carry our eyes across billions of kilometers, that we can look back at ourselves from the edge of forever and still recognize what we see. It shows us that distance, rather than diminishing our significance, actually illuminates it, because in all the images ever taken from space, in all the photographs from all the planets and moons and asteroids and spacecraft, there is only one world that shows the unmistakable signs of life. Only one world wrapped in blue and white and green. Only one world where lights flicker at night across connected continents and ships trace patterns across vast oceans. That world is ours. That world is home. And no matter how far we travel, no matter how faint Earth becomes in the cosmic darkness, it will always be where we began. From every planet, Earth looks different. From Mercury, it is a brilliant evening star, visible in the twilight glow. From Venus, it would blaze through any telescope pointed outward. From the Moon, it hangs in the sky like a blue marble suspended in darkness. From Mars, it is a bright point with the Moon visible beside it, still recognizable, still home. From Jupiter, it fades to dimness, becoming one among many. From Saturn, it shrinks to less than a pixel, captured only through careful imaging. From Uranus and Neptune, it requires effort to find. From Pluto and beyond, it disappears entirely into the cosmic background. But from every single one of those vantage points, Earth is the same thing. Home, the place where we evolved, the place where we learned to wonder about the stars, the place we are trying imperfectly and often tragically to keep habitable for future generations. That pale blue dot contains every sunset you have ever seen, every person you have ever loved, every book ever written, every song ever sung, every dream ever dreamed. It is everything humanity was, is, and will be. And it is out there right now, spinning through the cosmos, visible from some worlds and invisible from others, but always, always there. Look up tonight. Find the brightest star you can see. Imagine standing there. Now look back. That is the miracle. That is the message. That is what Earth looks like from every planet in the solar system. A point of light, a pale blue dot, a memory of home, and everything that ever mattered to anyone. But I want to leave you with one more thought, one more image to carry with you. In August 2012, Voyager 1 crossed the heliopause and entered interstellar space. It was the first human-made object ever to do so. As I record these words, Voyager 1 is still out there, still transmitting, still carrying the golden record with its collection of sounds and images from Earth. On that record, among the greetings in 55 languages and the sounds of wind and surf and human laughter, there is a message from then US President Jimmy Carter. It reads, in part, "This is a present from a small, distant world, a token of our sounds, our science, our images, our music, our thoughts and our feelings. We are attempting to survive our time so we may live into yours. We are attempting to survive our time so we may live into yours. That is what the pale blue dot represents. Not despair at our smallness, but hope in our persistence. Not resignation to cosmic insignificance, but determination to reach out, to explore, to understand, to connect. Every image of Earth from space is a love letter to the future. Every spacecraft we send into the void carries with it the hopes of a species that refuses to believe it is alone, that refuses to accept that the cosmos is empty of meaning. We are the universe becoming conscious of itself. We are the pale blue dot that learned to look back. And from every planet in the solar system, that is what Earth looks like. The place where consciousness first understood what it was seeing. The place that sent robots to other worlds just to find out what home looks like from far away. There is no guarantee that humanity will survive. There is no promise that we will colonize Mars or reach the stars or endure for millions of years. The universe makes no such promises. But there is this. For now, right now, in this brief moment of cosmic history, we exist. We wonder. We explore. And when we look back at Earth from Mercury or Mars or Saturn or the edge of interstellar space, we see something no other species in the known universe has ever seen. We see ourselves. That is the gift of perspective. That is the power of distance. That is why these photographs matter. Not because they show us how small we are, but because they show us that we are capable of seeing ourselves as we truly are, and still finding reasons to keep going. The next chapter of this story has not been written yet. Humans have not yet set foot on Mars. We have not yet sent probes to the ice giants. We have not yet built telescopes powerful enough to image Earth-like planets around other stars. But we will. And when we do, when we stand on Martian soil and look up at that faint blue point in the sky, we will remember this moment. We will remember the first images, the first explorers, the first generation that dared to look back. We will remember that we came from that pale blue dot, and we will carry it with us wherever we go. That is what Earth looks like from every planet, everything, and the promise of everything yet to come.